Okay, good afternoon. Welcome to the 9th session of the spring semester at Sunoikisis Digital Classics 2020. This is the last of this short semester. This session will be on text and data visualization, or as it's sometimes called, LIES. And we are being joined by Aurélien Berra from the Université Nanterre and Matteo Romanello from the École polytechnique fédérale de Lausanne, who were both here, and Dimitar Iliev from the University of Sofia is my co-organizer and is also here with us in the video. I believe we're handing over to Matteo first with the general introduction.
Yeah, thanks, Gabriel. Yep. Yeah, so before we actually go into the matter, just a brief outline of the session. We are going to start with some introduction to the data visualization, good principles, potential problems, and conclude this section with a bit of discussion on this, opening the floor to discussion. Then we'll move to Aurélien, who will present, talk about the visualization in the context of textual analysis, exploring Homer using the Voyant Tools and also beyond. And I will conclude with an example of visualization used in digital classics research to visualize quotations and references to Virgil's Aeneid. Okay, so before we start, just a word about the place of visualizations in the workflow of working with data. As you see in this image here, visualizing data is not only at the end to communicate the results to the wider public, but it's very much in the process of transforming data, modeling them, and visualizing them to get actually a sense of the data. So it's not just an error, it's really a loop. So it's very much visualization as part of a workflow of working with data.
Matteo, just a note, we're not only seeing your slide, we're seeing your whole browser window. You know that?
Yeah.
We're
I didn't know that. So I'm going to go in the present view. Yeah.
Great. Okay, just checking.
No, thanks for that. Yeah, so very useful reading, a bit dated, but very much still useful is the book by Edward Tufte, The Visual Display of Quantitative Information, published in 1983. But actually, a couple of quotations that are here are from the second edition, 2001. Tufte formulated in this book principles and guidelines to go about visualizing data that are extremely useful. So we accepted a couple of quotations that you find in this slide. For example, graphic excellence is what gives to the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space. So here he's talking about printed visualizations, but you can just replace ink with pixels and it's still valid. And also introduce some concepts like chart junk that are very useful when talking about bad visualizations, and we will see later in these slides some examples of chart junk. So a bit about the purposes of data visualization. So visualization of data is what makes quantitative data legible and intelligible. And this is true for oneself, but also true for the others. So when visualization is actually to accomplish this task for oneself, it's more about data exploration. So visualization as a very useful means to actually know your data. So it can be, to me, happens quite often to notice some outliers, some exceptions, some weird things, even in my data, only by plotting them, by visualizing them. But then the other big purpose, important purpose of visualization is actually to communicate the results. So visualization are extremely powerful as a way of conveying some information about quantitative data in a visual way. At the same time, data visualizations can potentially tell fake stories. So as we will see in the examples of bad visualizations, certain aspects of visualization can be used to actually manipulate and alter the story that we're telling, and they very much change the perception of how the data is perceived by the viewer. And the other important thing, especially in a digital humanities context, is to keep in mind that the information we are visualizing often comes from a process of extracting the data. So not just receiving it, but capturing it, extracting it from other sources. So in the visualization, it's important also to be transparent about the fact that the data we are visualizing and displaying, they actually come from a process of interpretation that needs to be also made transparent to the user. Just to repeat it, it's important to weave visualization into the process of data analysis, because visualizing data through figures and plots helps us to understand potential bugs in the data or some characteristics of them. And the other aspect, when these figures and these visualizations are produced automatically, means by means of code, it's important to share not only the image itself, but also the code that is used to produce it, as well as, when possible, the underlying data. So some basic principles. Not all visualizations are equal, meaning each visualization has a given, is suitable to visualize a certain type of data, suitable to a certain context, and different visualizations have different rhetorical strengths. Some visualizations are more suitable than others in relation to a specific data set, but in some cases, visualizations are not suitable at all. There are cases where a table is actually much more suitable than a plot to display a certain data set or a certain aspect of the data. Two principles that are important when visualizing data that come from Tufte. One is to keep it simple. Keep it simple means breaking down complexity, means also not using some visual features that are actually distracting for the viewer. And the other one is to keep it true, meaning the visual features in the visualization, there needs to be proportioned to the quantity represented. And that's where especially scales of a graph can be used to lie. And we'll see this in an example. So there are two main components in visualization. One is aesthetics, which relates to everything that is the position, the shape, size, color, line width, or line type. And on the other hand, you have the variable, so the quantifiable things that you are displaying in the visualization. And then in the type of variables, we will not go into details about giving examples of all of them, but you have distinctions between quantitative variables, qualitative variables, ordered and unordered ones, whether your variables relate to date, whether relate to time or to text. And visualization is all about finding an efficient mapping between the variables, so the things for which you have the data, and the aesthetics, so the visible dimensions of your representation. Just a brief overview of the type of visualizations. So whenever you're dealing with amounts, there are bar plots, grouped and stacked bars, histograms, and heat maps. We will not show examples for each of them, but I very much suggest you to check out the galleries that we linked from our references section in GitHub, and I just wanted to show there are two galleries, one for Python visualization, the other one for R visualization, but they are extremely similar. And I just wanted to show how they actually present different types of visualization according to the different purposes of the visualization. So whether you are showing a distribution or a coloration, or you want to emphasize the ranking or the fact that the variable to show how it is part of a whole, then you have these different types. So I very much encourage you to explore these galleries. That will give examples for these main types that I'm covering here. So we talked about amounts. In some cases, you want to see distributions of your values in your data set. That's where the cumulative distribution or density plots and the box plots come useful. Whenever you want to show proportions between different things in your data, that's where side-by-side bars and stack bars are useful. Pie charts, it's there in the list, but we will see in a moment that actually it's recommended not to use pie charts. If you're interested in showing the relationship between two variables like x and y, and especially to potentially see some correlations, that's where scatter plots or time series are useful. And then for geospatial data, there are other types of visualization that actually relate the geographical dimension with some variables that you want to display. And one examples are these choropleth maps, where you can actually see different regions colored in different way to display the values of a certain variable. In this example is that the fraction of Australians identified as Anglican. So here you see a certain variable overlaid on the geographical dimension. I think at this point, we conclude with two small remarks. One remark about representing uncertainty. So uncertainty can be there in the data, especially in a DH context. And there are some elements of visualizations like error bars or confidence bands that can be used to represent in a visualization this uncertainty. And the other one is the use of multiple figures. So panels where you repeat the same plot, plotted relatively small. For example, to plot variation over time, then you're repeating a bar plot, one for each year, one for each decade, and this is very useful to allow for comparison. So if what you want to encourage the viewer to do is to compare data at different points in time. So at this point, we wanted actually to open the floor for a little discussion. If anyone wants to comment on any type of visualization that we presented here, and especially if anyone wants to say anything about a given type that has proved to be especially useful in their research.
So were you also going to show examples of some misleading visualizations, Matteo? You're still
I think you should unmute yourself. Yeah.
Sorry, in a moment. So should we first look at examples and then having the discussion, or can we use the discussion?
So I was just so that I won't comment on misleading ones until you've shown them. So discussion on what you've talked about so far.
Or maybe for the sake of time, we can just go quickly through the examples and then having a discussion at the end, seeing how much time is left.
Okay.
Okay. So I go back to the slides. Okay. So this I'm gonna skip it just because it's also listed in the resources we have in the GitHub. I wanted to mention network data as one of the examples where there is so much information sometimes in the network, then you don't actually manage to have clarity in your visualizations. And there is a paper that I linked in the slides actually talking about the usefulness or the danger of network data in digital humanities. So some examples of visualization done wrong, and this could be both in an innocent and in a not innocent way. So in a not innocent way to actually lie about data, and in an innocent way just to get things wrong. So the first example is the concern the y-axis. So as you see here, the y-axis in this graph starts from 9,100 and not from 0. This is very much not recommended because it gives you a distorted version, a distorted impression on the data. Here we see the same, actually the same plot with and without the complete y-axis. So it's about the average global temperature given in Fahrenheit over a long time span. Here you see how the variation is perceived on a long time scale if you have the full y-axis. And here it's actually the same data if you cut the time, the y-axis at a given value. I'm going rather quickly through these examples. You have links for each of them where there is a fuller explanation of this phenomena. The other way of lying or getting the visualization wrong, it's the so-called binning. So binning is when you group a given variables by ranges. So in this case, we are looking at income, and as you see here, the values that are plotted are binned, are divided into ranges of incomes. So from $1 to $5,000, $5 to $10,000, and so on. And as you see in this slide, binning is not an innocent operation. You can actually, depending on how you bin the data, you can tweak your visualization in a way that, as shown in this example, we can actually decide which part of the population we want to give the impression that gets taxed more. So depending on whether we want to show whether the message we want to convey is that we tax the poor or the wealthy, then we just bin the data in a different way. A readability of the data is when the colors and the number of variables that are displayed, or even the type of visualization, like the 3D, it's actually not improving on the clarity, but it's just cluttering the visualization. And the same goes for pie charts, where, for example, in the example of the 3D pie charts, the perspective of the 3D actually gives a wrong impression about the proportion of B and D, that they actually both 42%, but one is perceived bigger than the other. So this is what Tufte was referring to as keeping the proportion between the surfaces and the data, the quantities that are actually displayed. Another misleading effect is the one of the scaling. So in here, in the two cases, on the left, you have the proper scaling, the improper scaling, and on the right, you have the proper scaling. So on the left-hand side, you get the impression that the quantities you are displayed are actually different, that you have less cherries, but that's actually not true. It's just 4 for each of the fruit, just scaled in a different way. And then just a couple of examples for fun of aberrations of visualizations, where really there is a weird mix of visual feature and things got wrong about the actual statistics, about the actual visualization. To conclude, we wanted to give a couple of names of frameworks in different languages, and also for different purposes, going from data exploration to scientific communication. So some GUIs, and one of them, Voyant Tools, is going to be used by Aurélien in a few minutes, that you can use to visualize data are the Voyant Tools, Tableau in the public version, or Palladio. You have libraries. Here we flagged a couple of libraries in R and Python that can be very useful. So you have ggplot, which is a rather static library for data visualization in R, and Shiny, which is more interactive. For Python, similarly, there's Seaborn for static data visualizations, and Dash, which is based on Plotly for dynamic interactive visualizations. And then whenever you want to embed your visualizations in a web interface, then you might want to go for more JavaScript-based solutions like D3.js. I think I'm gonna stop it here. Sounds like a good moment to have the discussion, Gabi.
Yep. Open to everyone. Also, if you're watching this live, please feel free to add comments and questions. If you're not watching this live, you won't be able to add comments and questions, and even if you did, we wouldn't see them. Please. Aurélien, Mitko? I mean, the most interesting thing for me about these, the misleading visualizations, is that by having it in a mathematical looking visualization, you give the impression, instinctively we get the impression that there's accuracy involved, and therefore that it must be true. And people obviously take advantage of that by using the misleading visualizations to try and give the impressions they want, which is why it's so important, as you pointed out, to do your visualizations, correctly and not misleadingly by accident, because that feeds into this culture of the inaccurate visualization. The example that I accidentally flashed on the screen while we were shifting back a second ago is my favorite example of the misleading visualization. That in the UK, it's the Liberal Democrat Party are famous for this. They rely on being the second biggest party in several places, and therefore telling people don't vote for the third party. And this example shows a perfect example of this. That the scale is clearly completely wrong on this graph. It's completely misleading. And deliberately so. It's in order to make whatever is the third party look as close to zero as possible. And there are worse examples. This is just one picked at random, but that makes, and that's why I said in the introduction, visualization is sometimes known as lying, because every visualization is in sense it's a manipulation of the data, right? So we have to be extremely careful with what we do when we use visualization.
And also, if I may add, not only as a producer of visualizations, but also as a consumer of them. And there is so much of visualizations in the newspapers, in advertisements, in political propaganda, that it's very important to be able to have this kind of few basic things to pay attention to when actually looking at them, as a way of demystify them.
Yeah, I think that we could develop that topic of different cultures. I mean, digital humanities is sort of bridging different domains in which visualization as a scientific process can be well embedded, a very usual practice, or something quite new. And that's very interesting because visualizations can be very colorful, playful, and they can look very serious at the same time. So you always wonder what the viewer is going to think of it. Can he read it, understand what actually is said about the data in the graph? Can he appreciate it without thinking, oh, that's the newfangled, colorful chart that someone has been trying to make? Or on the contrary, oh, it's the boring, usual statistical analysis that doesn't tell me anything about my corpus in the end. So it's tricky to navigate between cultural and technical requisites for that.
Is it possible to? I mean, is it possible to reliably and responsibly publish a visualization with no commentary and let the visualization do the talking?
I'd say no.
Good, that's what I was hoping.
I'm wondering something else in connection with this. Well, about manipulations, that's more or less clear. The way that the times when you could unconsciously produce a faulty visualization based on incorrect distribution of data or something. Is there a way to check if what you have done is sound and is a meaningful way of representing data?
Maybe I can try to.
Well, give an example when you can produce.
Go ahead, Matteo.
Yeah, I didn't want to interrupt the question, but I think actually to check if the effect of the visualization is actually reached, I guess the best way is to check with users. So to do some sort of user-based evaluation to actually see whether the user understands what you wanted to convey with the visualization. But if you meant rather to check the data, I would argue that visualizing in itself is a good way of silently checking your data, because it immediately allows you to spot some weird things, and it prompts you to have this circle of noticing phenomena, going back to the data, checking them. And I cannot tell you how many times I actually spotted weird things just by looking at distributions. So many times we think of the visualization as kind of the end product, but its place is very much also in this loop.
Yes, and if I can add something, I think it's not just a loop for the one who is doing the exploration, but also for a viewer to get a critical sense of what is being done. It's very important to think not of static graphs, but as you said, interpretations embedded and outside of the graph, and to think of environments. And that's what we're going to say next, that the most important thing you can do is play with data and understand why you want to do that visualization. So interaction and then dynamic visualizations are not just toys, but actually the way to understand, and understand by doing things.
Yeah. And I think
that's
on
why
this
it's so
note, we
important.
can move to...
Yeah, please go. No, I was just going to say that perhaps this is why it is so important to accompany your visualization to exact description of how you came up with it, so that your audience could critically explore it, so you could further explore.
And also just to say what it is you think your visualization proves. If you're saying here's a distribution showing this peak in data point C or whatever, then people understand that what it is you're trying to show. Whereas if you don't say that, they might see that peak, but that might look obvious to them. But this trough down here somewhere else that they think is the important thing, and they might think that's your point. So just labeling it and saying here's
Even though not all visualizations are necessarily aimed at making a point, there are also visualizations whose goal is really the interaction. So they want to actually not to convey any specific message to the user, but just presenting it themselves as a way of exploring some data. So not all visualization actually want to convey a given message.
But still, what information is gone into the graph,
Absolutely.
has gone into the visualization, needs to be made clear. You know, those red dots that you're playing with are examples of X. That sort of thing, you know, that might seem obvious to us. But I think your point, and Aurélien's point about one of the best ways to test your visualization is to use your visualization as a way of checking your data in the first place. And if you do that, you'll end up going through multiple visualizations until you find the one that is A, interesting to you, and B, not misleading to the viewer. And that iterative process, I think, is very useful.
Yeah, I may have an analogy. It's an impromptu analogy, so you'll tell me maybe it's completely wrong. But for classicists, it could be interesting to think of it as the difference between an edition with a translation and the original text and notes, and just translation or just an edition, which are completely different beasts in the end. You don't really know what the person was understanding, even if when it's the best specialist, just printing Greek. What exactly? If you don't have an introduction, you don't have notes, and you don't have a translation, you always find passages in which the sense is elusive, and you don't really know why they haven't justified what you are trying to understand yourself. Maybe because they didn't have an answer, but why not say it? Yeah.
And does the reader understand your use of sigla? Does the reader understand when you've obelized a bit of text? Does the reader understand your apparatus in the way that seemed obvious to you? Yeah. No, it's good. It's good analogy. Yeah. I was wondering if we turned that question, if we just ask that same question. How do you make sure your visualization is doing what you want it to do if the purpose of your visualization is to mislead? Or is that not something we want to speculate on? The purpose is to show only one side of the data, because that's the thing we really want to emphasize. Would the answer be different? I withdraw the word mislead from the question.
No, it's always more fun to think of aberrations and things that go wrong, and I mean, especially in visualizations, it's a sport on its own. But I think there's a very, very important deontological issue here, because in the experimental sciences, it's the whole difference between something that's completely wrong and something that's going to be a breakthrough. I mean, when in Nature you have a paper that is being retracted because they have photoshopped, blotted a figure, or just made something that wasn't as clear as it seemed on the graph, it's a real scientific problem. So I can't come with examples like just now of similar problems in visualization that would have been produced on classical data, but probably we could find something. I mean, even just things as obvious as showing frequencies that would be just not proportional to the length of the text, not relative, but just absolute, and that in many cases is just plainly misleading.
There's a very minor example of that going to appear later in this presentation, I believe, which, whether or not Matteo will point it out, I will.
Good.
Shall we move on to Aurélien?
Maybe we could.
Yeah.
Mitko, did you have something to add?
I was going to add, but it's not as important. But anyways, that in quite a lot of cases, probably the initial cherry picking of data is what is the problem, and not visualization in itself. So if you have your initial data set wrong, then whatever visualization you produce. So it's not maybe at least half of the things that we are discussing now here are not problem of visualization per se, but could be any sort of data manipulation could yield wrong results if you don't have your initial data set right. So maybe at first point think about that.
Yeah, I mean, we've been talking, and we will still be talking in the time left about visualization as an iterative process, etc. But it does take a lot of time to get a visualization really, insightful, entertaining, or attractive or interesting. But it takes even more time just to prepare your data. I mean, that's the usual saying that you need 80% of the time just to prepare the data. And if you prepare it in a wrong way, then visualization is only be as good as your data, obviously. Shall I go on with the practical part of the session?
Please.
Yep. Okay, so as we enter that second part, I just want to say that these are examples through which we want to stress a few principles and ideas that we have been stating in the initial slides. The general point would be that if you want, tools embed theories. And the people who wrote us Voyant Tools, the environment I'm going to present to you, are very well aware of that, and they know that visualizations are interpretations. That's why we are presenting Voyant, but at the same time, we listed in the references and gave as seminar readings the book that was published by Jeffrey Walkwell and Stephen Sinclair, who made this text analysis environment, because there's a very strong theoretical background here. And the background is that you have to actually think of what you do critically, play with text, that is your, this is a process, and you have to go wrong to get right, and you're just trying to see through your data, as they said at some point, and now the metaphor is reveal your text when you click on to import data into Voyant. But in other texts and occasions, Stefan and Jeffrey also said that you have to play with data and you have to screw around with data. One of the papers is called The Hermeneutics of Screwing Around. So that's a very DHE thing to do. So the point is that well-designed tools go a long way independently of the actual programming language they use and the procedures they propose to help you understand your data and present results. But also many manuals are tool agnostic. So we're talking about Voyant. I will allude to R. Matteo will be referring to another project in which other tools were used, but it's not that is very important in the end. You do with what you have, and you just have to do something interesting with it. Especially as, that's something I add, programming often makes you able to mix tools and methods, and very practically. I mean, integrating Python in an R development environment is just very easy now. It's been for a few years only, or even a few months. But you have libraries in different languages. To use libraries produced for other languages, I mean, the D3 JavaScript library we listed is something that you can use in R. And in Python, you can use other libraries, etc., etc. So the most important is to look critically at your data and your visualization. And I would say that visualization can be of any type, not just the ones we said in the slides, but also text on a page, figures on a table, in a table are visualizations. You know, in the end, the background is something like I think what the anthropologist Jack Goody in The Domestication of the Savage Mind said about writing being a way to formalize and make the human thought processes evolve. So this is all about a spectrum of views on the data, textual in our case, and close reading, distant reading, visualizations of different kinds, are transformations and views on the text. These are data that we make ours to make something interesting and see something interesting in them. So the goal today is for anyone listening and who would not have used Voyant, for example, before, to build confidence and feel like just throwing text at the environment and try to think differently about the data in the process. The sources, as I said, on the wiki page. Maybe Gabby, if you can switch to the screen, thank you. The data that we gave here at the bottom of the page are sources. It's text, so the Homeric epic text from Perseus. You have the links to the GitHub repository for the text, and I added text by Salus in case you'd rather read Latin, but you can throw at it just anything, obviously. Voyant itself, if I just open the classical standard Canadian URL of Voyant, is, and so it's written on at the bottom of the box, Voyant Tools is a web-based reading and analysis environment for digital text. So what you get when you actually enter Voyant, and I'll come back to that, is what they call a skin, so a full screen with different widgets in panes. So you will import the text, and then my point is that you have a dashboard here of different views of your text that you can change, we'll see that, with default tools opened when you enter first Voyant, and these may be some of the most interesting actually, but many more, and especially many more visualizations behind that you can actually load. But coming a bit before that, I will stress that this is an online environment, but you also have a server version, and so you can work locally with Voyant. It's all explained in the documentation for Voyant. You have the repository and this documentation, in which you also have, that's what I'm showing, a tutorial. It's not very complete. There are other resources. We've listed some. I have produced in French a tutorial that's freely available on GitLab. I'll be using that a bit, but you can easily find your way around Voyant anyway. The basis is that when you enter Voyant, this is the interface through which you import a text or a corpus. It becomes data that will be used and treated once at the beginning by Voyant. So technically, it means that when you click reveal, you're going to tokenize your corpus and generate all the statistics that are going to be used then, that will be available to Voyant to show you what you want to see in the data. So the visualizations, lists, tables, etc. are produced from the data generated at that moment. For example, oh yes, and you have many ways to import data. So you can just give it a URL and it will retrieve from the HTML what's online. You can give it a text that you copy, and it can be quite long. You can give it a file, obviously, or even, I tell you that because I'm using it in my demonstration after that. You can give it a zip file containing several files, and they will be considered as documents within your text, so that you can, for example, spoiler, see the different books of the Iliad or the Odyssey as separate documents that you treat together. So you're not stuck with just one linear corpus. It can have some structure. So when I say I will demonstrate that, we have decided that we should start with an English corpus. This is a site that you may know. It's taking all the definitions that were given in the Day of DH event, online event, and the data are in this CSV file. So if I just take preferably the raw version of that file, I could take the text, but I will take the URL, enter it here to feed Voyant with it, and reveal the data.
Zoom in a little bit, Aurélien. Just make it a little bit bigger. Thank you.
Oh, the screen bigger. Right, you're right. I'm just worried about the widgets and what they actually are.
Yeah.
Okay, a bit less, but that's
That's great. Thank you.
Is it better? Yeah, you're right. So you see here that you have the text. So since it was a CSV, it's not very useful in the textual, usual linear form, but you already see that you have the usual, yeah, let's do it like that, some form of visualizations, including the interesting and famous cloud, word cloud on the left, and trends, which are actually in different layers, showing you a bar graph, actually stacked bars of the different terms that are used, with lines joining the data points for each variable that would be the hits for this or this or this term. So this is a dynamic environment, so you can hide data, select what you do with it, and you have, depending on the widgets, some customization that is possible, like changing the type of visualization. It's not great as it shows on that screen here, the shared one, but then maybe if is it better? Let me see. This seems to be a bit better. You can see more of it, right? Okay. It's not ideal, but seems to be enough for you to see what I do. So different views in different panes, and I just want to go through quickly the reason why this is such an important project. It's that it's not one tool, it's not trying to do everything, it's an evolving tool that's rooted in a text analysis portal that was built in the 1990s in Canada and evolved into what has become Voyant. And Stéphane Sinclair and Geoffrey Rockwell are very much part of the community of digital humanities and have been trying to integrate more cutting-edge methodologies, but basically you want just to have the statistical baseline of textual analysis available at all times. So the principle is that Voyant Tools is quite a flexible environment, also in the sense that it's contributive. For example, the language localized versions have been done by members of the community. I have done the French version of the interface, and at some point there was no Greek or Latin if you wanted to use stop words, eliminate common words that you want to filter out. So I just contacted Stéphane and I said that I was ready to try and do something. I prepared stop words and we had several versions, and they're now the default Latin and Greek lists in the tool. So if something can be better in your opinion, just contact the developer and work with him on it. So it's been an important tool for that. I would like now to go through a few of the widgets, stressing especially the visualization dimension. First, that word cloud, the Cyrus. Obviously, the first thing that will strike you, even without need for you to tell me, is that it seems not to be completely relevant because you have O1 arriving here, coming from my data, you see, and you have digital humanities, since these are definitions that takes all the screen. So if you go to the actual tokenized version, these are the terms, and the counts, because it's mostly about frequencies, then you see why you have the quantitative data that underlies the word cloud and the other visualizations. So you can just choose which ones you're going to see, or, and that's the interface that I want to explain, use options, and you have them for each pane, in which you use the stop words. So if I say that it's English, or if I define a new one, I can just say that O1 and digital are not going to be taken into account. And now I can see other things, sort of zooming into my data. So I leave the English corpus and show you the local version. So that's just to tell you that it's possible. So you see, I have opened the JavaScript thingy window that starts on my web on a local server, a new window for Voyant Tools, and I have entered the Odyssey zip file that I gave you on the wiki. So you see from the start, I have the same problem. So I will use the Greek stop words. And normally this is, I know what's happening. It's about, okay, so it's interesting. It's about the form of the apostrophe, you see? In the corpus, it's not the same as in the data. So it's not tokenized the same way, so I can't just eliminate them by saying that they are not to be taken into account here. So I just leave it here for that. I'll do exactly the same with Latin here. So that was the silent corpus. Because what I want to do is just go through a few widgets. So this time it's Latin. And you see that the results are more relevant. And this is a good example of noise, because I have extracted the data from the Perseus file, in which I was using the lemmatized file. This is why some terms have remained, like period. Okay, so this time you have filtered out what is usually not considered in an analysis, and you see things that are more directly relevant. So the Cyrus is just a gateway to your list of terms, which, as I said, as I argued, is a visualization. But it's more interesting to see beyond the terms and the frequencies what happens in the reader. In this form, it's one word on each line, so it's not very interesting. But since it's lemmatized text, in any case, that's not something you want to read continuously like that. And context here, bottom right, is concordance. So the keyword in context form, which is a very classical way to approach a text, is interesting also because, as you see, the widgets are connected. When you actually do something on one, another one is activated and can show you something different. And that's not obvious at all with the tools, more elaborate tools that we can use. And in programming, if you actually want to do that, you have to work quite a bit. So as far as visualization is concerned, some of the widgets are listed by the programmer here in this visualization category. Some, if you go and see them, are very useful, and some are clearly experimental or, let's say, more playful or even autistic. I will show you one which I find interesting here to tell you that this is the famous hairball in a way, the one we saw when network analysis is done wrong, but you can actually choose how many terms are displayed. So if you don't take a maximum, but like 25 here, it starts to be interesting. And it's dynamic. So that's an interesting way to see this. And a different one, verging on the useless this time, would be Textual Hog. But it's actually inspired by artistic performance, digital art in a way. It goes from one word to another one and displays the results as an itinerary with the text, with the size showing the importance of the text, of the words in the text. So what can you do with that? I don't know. It may be thought-provoking at some point, but it's clearly not something that you're going to embed to explain something about your text. So between the bar graphs that we saw in the more traditional view and this, you have the full gamut of what you can do with visualization. And these are terms that frequently appear together. And last one, a scatter plot, to show also that it looks quite compressed in that window, but obviously this is all HTML. You can export a URL, and in a new tab, you will have a full view of the widget as an independent tool. And this time, such a scatter plot can be used actually. So if you see all these buttons and lists, you realize that for some tools, you do have quite some control on what is happening, because these are the usual limitations that we mentioned for Voyant Tools and environments that try to do everything at once. They are easy to use, they connect tools, which is great, but you have to reload your data if you change something, or you have to work with several screens. If I want to compare the lemmatized and non-lemmatized version, I have to have several windows open. It's mostly about lexical analysis. It doesn't really aim at using explicit structures in the text, like paragraphs or encoded structures. If I have encoded the characters in the text, you can't do that with Voyant. It's not the point. So it's more basic. But at the same time, it's all there from the start, and it's a very good start to explore your data. There's one aspect, and you can see, that such visualizations can also be embedded in any web page, as they do in this recommended reading. This is Voyant fetching a preloaded corpus, and it's dynamic. It's just a Voyant Tools widget used in a web page. And to conclude on that, on the limitations and difference with programming, I just show one example of working with Honor. So I have already actually loaded. So this is RStudio with R code. And I'm mostly using the tidy text package here because it has very convenient functions. So what I want to show is that I'm just importing data, lemmatized and non-lemmatized, using subwords. So that's just what we talked about. You can visualize with ggplot, the package that was mentioned. You can obviously visualize this, and I will make it a bit larger. And here we have a bar graph of the words that are most used in the non-lemmatized Iliad. Okay, but if you look at the code, you see why we talked about the grammar of graphics, which is what the main hand in ggplot, Hadley Wickham, called it, was actually drawing on the grammar of graphics, and this is what he was trying to do. There's a logic here. You just say that you're using the data you have prepared. You actually integrate the fact that you want to count some elements. You take a part of the data, so that these are things that you can't do with Voyant Tools. It's just the whole corpus first. And then you plot, saying that first you want the aesthetics. We had that term on the slides. This is what you want to show, and the feature I'm going to use is the words, the terms used, and the number of times these words appear, so the frequencies. And once I said that this is what I want to see, I say what kind of visual form I want them to have in this case, a bar plot with columns called. So if I do that, this is my result. And the interesting thing is that it's more logical. It makes it possible to customize, change just a detail and restart the visualization. This is why it's really iterative. And it helps you because things can't really go wrong. I mean, the data can be bad. You can not understand maybe what you're doing, but there's a sort of logic that keeps everything together and makes it much more difficult to do something that's meaningless. And then you can add all sorts of detail, obviously, about the theme you're using, or flipping the axis, for example, which is very useful when you work with text. So that works for a bar plot, and you can obviously save files. You can do that in Voyant as well. I'm not repeating that with the lemmatized versions, but you see that you have all the kinds of toys you want, like WordCloud as well. And to conclude on that, I would like to show you an example of small multiple, because this is something that we've mentioned and something that cannot be done with most usual tools and not with Voyant. If you want everything to be displayed at the same time, here I have joined the Iliad and the Odyssey corpora, so I call it Homer as a whole. I will ggplot my work from Homer. I say that I want the relative frequencies of words, and I want to determine each time by an aesthetic which work I am representing. But what I do is I do a histogram and I do facet wrap. I'm using facets. So the result is that I'm doing the same operations for several features in two corpora, Iliad, Odyssey. And this is very useful when you actually, that's the one I wanted, the more useful one, to do something like this. Compare these two corpora. Look at this. This, I've been calculating actually the TF-IDF. So these are the salient, the relevant words, not just the most frequent words in both corpora. But you see that in the most frequent, the most important words in both corpora, in a bar chart like that, if you use small multiples, you actually compare them. And this is very difficult to do otherwise. We could talk about all sorts of different possibilities that you have when you actually do it through code, but I just end with this notion that this is fully reproducible, because if you give your code and you give your data, anything you have done has been done by the machine and not through clicks and buttons that no one can exactly reproduce. So this action is something that is as stable as can be, and it's more flexible. In the exploration, Voyant Tools is a very, very incredibly easy to use tool. But if you really want to customize results and, for example, quote, integrate a graph into your publication or web page or anything, it's very often done via programming if you want to do it well, because you can customize, but you don't do it by hand in an Adobe or any other kind of software. So this is important in the perspective of open science, let's say, and we have been using Perseus test because we do think that this is probably the right perspective. And with these words, I'm very happy to have your questions, comments, and see what we can think beyond what I said.
Thank you, Aurélien. Anyone Anyone wanted to ask a comment or anything?
I have always wanted to ask about the word clouds as a means of visualization. There is one of the options from Voyant Tools also elsewhere. I have always thought that they're a bit, well, they're not exactly a method of exact representation of data. They're more or less vague or impressionistic, or they give the impression of being so. What would you recommend them for? What are they good for, and what are they not? Definitely not good for, and could be misleading. Because I personally, maybe it's just me, I don't know, I take them with a great deal of precaution. I mean, they don't speak to me much in terms of data processing and yielding some meaningful and non-trivial results, things like that.
Okay, it's a very interesting experience for me. I got everything you said except the very first sentence in which you said what you were talking about. So I know what you think, but I don't know about what you want me to add something. What was the form of visualization that you were commenting on? If anyone can tell me. Okay, right. Good. So yes, some people just hate them. I think personally that it's partly because we want to feel distinguished, but if you just see word clouds as an introduction to a list of terms, that makes it quickly apparent which words are very often used, it's fine. The trouble is that they've been used without a context, without interpretations, as Gabby said before, and printed on the first page of blog posts and books and anything, very much including non-academic productions. So I think it's a cultural perception in the end. I'm not saying that you can do anything, but if you have a dynamic word cloud, look, you have the number of appearances of the word here if you go and hover. So it's not that bad. I wouldn't say that they are very useful, especially printed, because when static, it doesn't mean much. But in this use, I would defend them a bit, because if you click on Odysseus, you actually quickly see that it's a pretty important term in the Odyssey, and that it appears with this distribution on the widget. So yes, obviously they're not the scientific tool par excellence, but if you actually use them in more interactive context, why not? Because you go further than just looking at the 25 first terms of your frequency list.
Thank you.
Aurélien, could you say anything quickly about adding stop words for languages that they don't already have?
Mm-hmm. So there are, not mute. Two types of answers. The short one is when you go to the options for any pane, you can use a predefined list, but you can also start a new one. It will be empty, and then you can edit it, the empty one or any other one, because it's going to be turned into a new one. So if I take Breton, which I don't know at all, I can edit the predefined list with words that actually don't exist in Breton. But then if I save it, it's going to be a new list, a custom list. So I could do anything on the fly. And then you can also go a bit deeper. You can work with the local version, and then what you get actually when you use local version is a directory in which you have all the files, but also if you get to know a bit Voyant, you have resources and you have the actual stop words list in that directory. So in the documentation, you can find how to do that. Since I had to develop lists, I'm more familiar than the average user, but it's quite possible to do that. And since it's a community and the developer is very friendly and open to interested in any kind of collaboration, if you actually think that something should be improved or that we should have Breton 1, Breton 2 for specific uses, or ancient Greek and ancient epic Greek, for example, then you can just ask if you can permanently by default integrate some list into Voyant. But my guess is that the answer that Stefan would give you is that Voyant Tools is here to cover like 80% of the needs of someone working with the text. So if you're trying to do something more elaborate, it maybe means that this is not the right tools for you right now. Because if it's just on the fly modifying a list, you can do it already. And if you want something very specific, maybe this is not the tool you want to use.
So the other part of the answer might be that the stop word list you're looking for may exist somewhere else. And
of course.
It could be as simple as copying and pasting it into...
Exactly. And that's what I did first.
Yeah.
I recomputed lists from various corpora and the TLG, etc. Because when I wanted to do that, I went to the Digital Classicist Wiki, a very nice resource, guys. And what I did is that I realized that it was wrong, and it was short, and it didn't cover much of the let's say the low and the high of the corpora we're using in a chronological perspective. So the trouble with that, stop words used are usually still taken from the web, from the search engines, which actually had to develop them. And search engines for ancient Greek and Latin are not very performant. So we needed something else. And that's why we had to redevelop it, actually. Yeah.
And for most of the ancient languages we're interested in, the CLTK have a fairly good selection of stop word lists. Yeah.
Yeah. So I may add something on that. It's a very interesting comparison. So CLTK is a Python set of libraries that is based on the NLTK, so natural language processing with Python and the T for toolkit, TK, but they are using a different technique. First, they had stop words, lists like that, and we discussed that with them as well, but they have been evolving towards, I think, a very interesting perspective in terms of linguistics, because you compute for each corpus the stop words you need. So it's more algorithmic based, and it makes a lot of sense. It has drawbacks. You can't edit the list the same way, but if it's programming, then you're free to do whatever you want. Yeah. So they have a great rationale that what they're developing for that. So you will find the resources by Patrick Burns, especially. And he's been talking about that and implementing it into the CLTK for 3 years maybe.
Yeah, I was just attempting to answer the question myself before I asked you it. And I was trying to find a stop word list for a particular language that has no stop words in that. And so I just Googled for it and I found it in CLTK. It was, of course, a JSON file. So I just simply opened it in a text editor and stripped out all the commas and apostrophes, turned it into a simple list and pasted it into Voyant. And I assume it worked, but it's a language I can't read, so I've actually no idea. But it does seem fairly straightforward. Yeah.
But we do have the Digital Classicist Wiki a nice page for stop words now.
Okay, cool. I'll go there. Anybody else want to add anything? Then maybe we should move on to the final part of the presentation, as we've already used up quite a bit of time. I hope we're not keeping you too late. Matteo?
Yeah, so let's go quickly to the to the last section where we actually wanted to show an example of visualization for research. Before doing that, we just compile, if you want to have some examples of visualizations in DH, a place where I like to start from is this community-driven resource, which is the DH Awards website. So it's an initiative where the DH community is voting every year for the best tools in several categories. And there is a category for infographic visualization, data visualization, has changed a bit the name over time. And here you have the winner for each year. So it's an interesting, if you're looking for examples, that's our selection based on the DH Awards. My favorite is the coin collections visualization done by a visualization lab in design lab in Potsdam, but there is no time to actually say why I like it so much. But the example that I wanted to present as a brief use case, it's from my own research. So it's a good moment now to move from the slides to the actual visualization. It takes a moment to read, to load. So I have already prepared in the tabs a couple of parts that I wanted to show. So first of all, what kind of data it allows you to see. So what you see in this visualization is quotations and references of the Aeneid, of Virgil's Aeneid, extracted from the JSTOR corpus. So all the JSTOR articles classified as belonging to classics that quote or refer to the Aeneid. Since we talked already about showing and explaining the fact where actually the data comes from, in the about, you have a brief section on how these data were produced, so how the references were extracted, how the quotations were captured, with also links to the software. To say something about the reason why I built this visualization, it was very much a reason of communication. So after having spent a few years doing a PhD on how to extract automatically references to primary sources, including the Aeneid, I ended up, after a few years, with actually nothing to show, to communicate in a kind of intuitive and visual way how this could be useful for the actual research. So that was my main motivation in actually developing this visualization, having something that I can point to people to exemplify how capturing these references allows you for an easy access to the bibliographic materials about classical texts. So let me now unpack a bit this visualization and also kind of the different levels you have in it, because it's I think it's quite dense. So first of all, we said there are two types of data. Here you can select it in the display drop down. You can display quotations and references, or either of them. So this will be the data that actually gets displayed. And the visualization is interactive, so very much like Voyant, acting on the different parts, especially on the left-hand part, changes the other two columns. What you see in the three columns, they actually refer to different levels of reading. So in the middle, you have the close reading of the text of the Iliad, being told at which chunk of the text you are looking at the bottom, always clear to give you a contextual information. So in the middle, there is the close reading. On the left-hand side, there is like the distant reading of this, of the quantitative aspect of these quotations and references. So first of all, the type of visualization, it's a heat map, where the heat, so the intensity of the color, actually means the density of quotations and references, or quotations or references. So essentially, the darker it's a given cell, the higher is the number of data points that you are visualizing. So here, for example, at the top leftmost cell is the very beginning of the Aeneid. That's where there is the highest reference of highest density, sorry, of references and quotations. So it's represented by a very dark color. One word about how what the columns and the rows mean. So the columns mean the books of the Aeneid, whereas the rows mean ranges of lines. And this is because to be able to represent the text as a heat map, I chunked each book of the Aeneid into, we said before, beams, so ranges of lines. So the first one is the first one on the first column is lines 1 to 50, 51 to 100, and so on. And the gray cells actually mean the absence of data. So in this case, the fourth book, it's shorter than 750 words. That's why 50 lines. That's why the other cells remain gray. So left-hand side is the distant reading. What you have on the right-hand side is the close reading, but of a different type of text, not of the Aeneid text, but rather of the text of the literature that it's citing or referring to the Aeneid. So it's actually this type of interface that mixes and blends different levels of reading of different sources has been called in the literature scalable reading. So what you do here is to move constantly from an overview of the most dense or the least dense areas of the text to actually read the text itself in the closed reading part, or if you're interested on what has been written on this passage, looking at the literature from JSTOR that is either quoting or referring to this. So just to show a bit how the interaction is always driven by the heat map. So in the heat map, you can select based on your interest passages of the text that will put in focus in the middle, and then on the right hand side, you will have snippets from the publications where a given reference or a given quotation is found. So here I can look, for example, only at quotations. I want to see why the middle of the sixth book it's so dense, and then I can continue here, seeing what kind of papers have been written, and I can read a bit around the quotations of the Aeneid found in this text. Then Aurélien was mentioning open science and open access. The trade-off here is that you can see a snippet around the reference or the quotation, but you cannot see the full text. So the full text it's still in JSTOR, to which there is a link, and then depending on your institutional access to this resource, you might be able to read more about the of the paper itself. But at least the snippet should give you an intuition about whether this could be useful or not for your research. This is what I wanted to say in a sort of quick version. Thinking if there is anything else to add. Maybe are there any questions from you?
Can I very quickly, can you throw that page back up, the visualization?
Yeah.
Back up a second. There's just something I've said earlier that I would mention, the misleading piece of information in this visualization, the main lie on this page. In your heat map, the darker the blue, the closer to black it is, the more densely quoted that passage of text is, and the lighter the green the least densely. So one might look at this and say, why are the last 50 lines of book 11 so little cited? Because that's the lightest thing in the whole thing. And I did that at one point, I clicked on that. And the reason that has so few citations is that it's only so 6 lines or something.
Yeah, because in that range there is a small number of lines. So that's actually very well spotted. And one of the things actually to improve on this visualization for those chunks where there is only a partial number of line, the actual frequency should be normalized.
Okay, I mean you could do that, but on the other hand, you could leave it as it is, because actually having it as an absolute number is another piece of information as well. And
yeah,
you know, if someone I want to choose a nice dark one because I'll have a long list to look at, they, you know, that then it is useful for them to see this as not having a long list.
Yeah, but of course, I mean the drawback of having these arbitrary 50 lines chunks is that you have some cases where the book ends and you only have a few. So in these cases, some normalization will be needed in order to make not to give the impression you are lying with the data. I totally agree.
I mean, it then becomes interesting that the very end of book 6, which presumably is slightly less than 50 lines, is nevertheless the darkest chunk in book 6.
Yeah.
So that's doubly valid, doubly significant for whatever reason.
I don't remember how many lines it has, but in case it's much less than 50, then if you normalize it, the color would be even darker.
It would be even darker, that's true, yeah.
Yeah. So, but just to say, I mean, not to comment on all the pattern that you see here, but if you look at this heat map, already you see how the first half of the Aeneid, it's compared to the second half, less quoted or referred to. So it's useful in order to get kind of a decent impression of how all these thousands of quotations and references are kind of distributed on the text. But then at the same time, to actually make sense of them, you want to go and see them and also see to what text they refer to. That's why the idea of the visualization was to blend all these different levels of reading together.
Yes, I'd like to stress that obviously this is easy to pick details and make comments, but this is what they would call groundbreaking in grant proposals, etc., because it starts with the actual uses that people in the classical scholarship communities are going to have. They want to access the secondary literature, but it does so through a visualization, so a result of statistical analysis. And what is most difficult in that is to do what you've been doing for years, Matteo, that is the actual references and link them to secondary literature. So that's to primary literature. So that's really a marvel, but it's a sort of prototype. And if you're speaking of misleading, the most misleading thing in the whole screen is that you don't see gesture anywhere. So you get the impression it's very dense, and it's, you know, you don't. But in fact, if you think of it, it's mostly English speaking. It's if you have 100 papers, because there's been some debate about a passage that were published in the 1920s in one journal, it makes the heat map go crazy. So you have so many parameters when you try to deal honestly with a corpus. It's impossible. You would need the full dashboard of Voyant-like analysis to be able to really set up the thing. And even if you have more diverse material than gestor, it's very difficult to think of what we're doing with our corpora this way. So this is about manipulating and trying to get accustomed to these type of access text.
Yeah, and if I might add one comment, it's also the going back to the difference between data and capta. One thing to keep in mind to look at this, as Aurélien was rightly pointing out, is kind of how representative is the corpus, what kind of corpus it is, so very Anglophone, but on the other hand, also the fact that these references and quotations were extracted automatically. So talking about putting in context with some narratives, this visualization, it should also be accompanied by an evaluation of the of how precise are these two techniques that produce the data that are visualized here. So it's very much an abstraction of a process of automatic extraction that has some implications, especially for the missing references and the missing quotations that you will not see here. So it's yeah, I believe in using this not really to explain what you see, but as a way of problematizing, for example, by showing what Gabi pointed out of the effect of missing normalization, or also the fact that what you see, it's only one part of the story.
Sure, and obviously, I mean, pointing out flaws in this is because we're discussing visualization, and it's the interesting features of visualization. This is an amazing piece of work, and any suggestions one might make, normalizing the last block, adding a feature to be able to filter by date of modern reference, to be able to filter by modern language. Those are all things one can imagine doing, but that misses the point of this, which was really a proof of concept, and an amazing proof of concept for this sort of the sort of visualization and showing the data that's underneath it. And it is really exciting. I showed this to a room full of librarians last year at a workshop that Matteo and I were at, but Matteo disappeared from just before his presentation. So I ended up presenting this, and they were extremely excited. It was one of the most exciting things that happened all day. And someone immediately asked, a medieval librarian came up and said, can you plug Dante into this? I want to see what that looks like. They immediately saw the point of this.
So about the normalization, I could say I actually did it intentionally for this session to actually show the flows of visualization, but of course that will be lying as well. So
we're all about lying. This whole session's about lying.
Yeah, indeed.
Yeah, about lies, I like happy endings, and I tried to show you the Odyssey and it didn't work. So I just want to explain why. It's because the text, as I said, had the wrong apostrophes, because it was not conceived to be used with Voyant. So I want to be fair to Voyant and give a good impression in the end. So it's very quick, 1 minute. First, I haven't detailed that, but if you, oh yes, thank you. When you import the text, you actually do have, apart from the interface in several languages, which is a very interesting feature, you have options. So it's not an infinite list, but you have quite a few options for pre-processing. So we could have made things better this way, but I did it the usual brute force way. I just corrected the apostrophes. And if you upload what I call corrected text, I will add it to the wiki. So it's just the same with different apostrophes. What you get then is this kind of text on which you can apply the stop words which actually know D-Day, man, etc. And this time, this is the Odyssey, and obviously Odysseus, Telemachus, Andro, Latini. Why am I trying to speak English Greek? Silly. Anyway, these are actually salient terms. That is the ones coming first in the list. So it does work. Yeah. Tweaking involved.
Fantastic. Yeah.
Yeah.
Any other questions or comments before the end? Anyone watching live want to leave any comments in the chat box? I don't see any in there yet. We've also gone longer than we said we would, so maybe everyone who was watching live has gone to have dinner. Did you maybe want to say a couple of words about the exercise you suggested before we go?
Good point. Shall I go ahead, Matteo? Yeah, good. Yeah, the exercise is actually about doing something with Voyant. So we have suggested the epic data and phallus, as I said, just because I had lemmatized versions extracted as well, which makes it more interesting to compare versions. But you can do it with any text. And if I show the wiki again, yeah, thank you, Gabby. I will just show it better here. The exercise is to think through Voyant Tools. That is, explore visualizations of the text you've loaded, try to understand what is interesting in applying stop-word list. I may point out actually that sometimes you don't want lemmatized versions. Sometimes you don't want stop-word lists. It does make sense if you're a linguist to see how many conjunctions you have in a text, or particles or articles, obviously. But then this is interesting to play with. But then once you settle on one visualization that seems telling, seems to have some meaning, you start to interpret it in just a few paragraphs or a few sentences even. But try to understand what makes it good and what before was more obscure or least useful for you. And you could do that with the lemmatized and the non-lemmatized versions. So we have the text here, and I will add the corrected lemmatized version. Yeah. And we are available if you want to discuss what you've been doing with that. But Gabby, you're in charge of that as well.
Well, only in as much as my students are concerned. Anyone else who's watching this obviously has you can deal with this any way you like. But if you're one of my students on ICSO 2, the Aurélien suggestion that you reflect on the results of your visualization and make a few notes on that. Please bring those to the class. I would like you to tell us all about what you tried to do and any thoughts you had about the results. So think of that in terms of, you know, spending a minute or two explaining to the rest of the group what you thought about your visualization.
And that's actually what I do with my students when I use Voyant Tools. I mean, at master level, we have a digital classics course. And what we do is that first semester of the first year, they don't have programming lessons at all. And we are using Voyant. So we are doing TI, so you can't do everything at the same time. But on year 2, they are using R. And in this case, they start to see what they can do that they couldn't do before. And that's an interesting combo, I think. So explaining what you see and what you don't see and what you would like to see is a progress, really.
Yeah. Very nice. Cool. Thank you. Any other final comments from any of you?
I think it was very exhaustive, not exhausting. So yeah, maybe not.
Cool. Thank you. Then in that case, this is the final seminar of the spring semester. We look forward to the summer semester, which Dimitar will announce very soon, and we'll soon learn what's going to go on there. So I'll just end by saying thank you again, Aurélien and Matteo, and see you all soon. Bye.
Thank you for having us. Bye.
Thank you.